Alright, let's do some examples. This is the first time I've gone through them. So a plumber charges a fixed call-out fee and then a set amount per hour. Okay, so set amount per hour is the rate of change, and if it's fixed call-out fee, that would imply that this is a linear relationship. So plumbers, when they come out, they'll charge you a fee to come out, and then for every hour it takes them to fix whatever's wrong with your pipes, they charge an hourly fee. So let's test if it is linear. I think I remember asking AI for some linear examples. Is the difference between this and this the same? So 130 minus 90 is 40, and for this one here, 170 minus 130 is also 40. So the call out per hour is $40. Okay. And then it says, what is the fixed fee? Well, the fixed fee is the cost. Notice this is total cost. Is the cost when time is 0. And it doesn't give us that. It gives us that it starts at t equals 1. So we're going to have to go almost like go back an hour of what they've given you. But we know that it's $40. So the cost at time equals 0 is going to be 90 minus 40, which is $50, which is pretty cheap actually for plumbers. Yeah, that's what it is. Let's do the equation. So the equation, let's say the cost as a function of time in hours is going to be 50 plus 40 times however many hours, and time is in hours. If it doesn't ask for that, but that's kind of implied. Next one. A stack of boxes is grown taller as more are added. So that kind of implies that this isn't going to be exponential or quadratic. It's probably going to be linear again. Boxes, if we kind of presume there that all of the boxes are the same height, then okay, so would it be a starting amount? Okay, so let's test that these are the same jumps. Notice these are in twos, but the fact that they're in twos is okay as long as it's consistent. It's in twos. So 58 minus 34 is 24, and 82 minus 58 is 24 again. Okay, so there it's 24 for each two boxes that are added. So each box must be 24 divided by 2, which is 12 centimeters. Okay, how tall is one box, and what is the starting height? Okay, so they obviously must be getting sort of stacked on a piece of wood or something. So there must be a sort of a piece of wood or something that they're on, and then the boxes are getting kind of stacked like that. So we know that these are 12 centimetres, and now we have to work out how big this block of wood is. Okay. It always helps to do a little, if you're not sure, just sort of in your head to sort of conceptualise it. So each of those, how much is the starting height? Okay, so if 2 boxes are 24, so if we took those 2 boxes away, so 34 minus 24 is 10. So this must be 10 centimetres. So it doesn't ask for, but I'll give it to you anyway. So the height, let's say the height is equal to 10, which is what we started with, plus 12 times x, and let's say x is number of boxes. There's our answer. Let's actually test it. So we've got 6, and say we didn't know what the answer was, so the height is going to be 10 plus 6 times 12 is 72. That's 82. So yep, it works. Virus. Okay. Viruses, as soon as you see the virus, you should be thinking, okay, exponential. Virus spreads rapidly by doubling each day. Okay, so they've told us the growth factor. And they've told us that it's exponential. Just explicitly. Okay, so it's exponential. So it's going to be some initial amount times the rate to the power of the number of days. So the initial amount is actually going to be when t equals 0 or x equals 0. It's not given, it's given there as r equals 1. But if we sort of went back a day, we could sort of say that if we put a sort of 0 here, it would be 1, because 1 doubled is 2. So it's going to be 1 times r, and the rate that's increasing by is 2, and then the number of days is x. So let's test it. So 2 to the power of 4, does that equal 16? Yep, it does. So the amount of bacteria is going to be 1 times, and I'm going to leave that 1 there, 2 to the power of 7. Which, if you do computer science, you should know that straight off the top of your head, but I'll just do it. 2 to the power of 7 equals 128. Which seems pretty conservative for a virus. Okay, so it's infected people. So 128. Yeah, that's pretty bad. 2 people with doubles per day. I think COVID at its peak was about 1.2. I think. So this is a pretty virulent virus. So you'd want to stamp that out pretty quickly if it was a serious virus. Okay, a bacteria colony triples every hour. So they've told us explicitly there that it's exponential. So it triples, so our rate of increase is going to be 3. And H is the number of hours. So rule for the number of bacteria after H hours. So we still want it, the amount of bacteria is going to be equal to the initial amount times the rate to the power of H. Let's sort of test that. And A is going to be the amount at time 0. So So the amount at time 0 we know is 5, and the rate is 3. Is that going to work? So let's sort of work it out. So let's sort of say the number of bacteria, let's say it's B. Number of bacteria. Does that work for one of our tests? Let's take 3 for example. Is 5 times 3 to the power of 3, does that equal 135? So 3 to the power of 3 is going to be 27 times 5, 135. Yep, it does work. So our final rule is that the number of bacteria is going to be equal to 5 times 3 to the power of the number of hours. By the way, don't multiply those to make it look like it's 15 to the power of h. Leave that 3 there. Okay. A farmer builds a rectangular pen using 40 meters of fencing along 3 sides, not the 4th wall, along a wall. Okay. What width gives the maximum area? So this doesn't look like it's linear because it goes up between there and there, and then it goes up, but then it goes down from there to there. So it's obviously not linear. It probably can't be exponential either. So this is probably quadratic. So it's going to be in the form of ax squared plus bx plus c, which are notoriously difficult to do unless we do simultaneous equations. We've got enough information here to do simultaneous equations. And after we've done simultaneous equations, we'll actually come back and do this, I think. So I'm leaving a little star for myself. 40 meters of fencing. Okay. So the area is going to be something. It's going to be a function of m. Is this quadratic? Well, let's actually cheat a little bit and use our table that we had. So I'm going to put those in. $15, $75, $100, $105, and $90, and we get -20 and -20. So it is quadratic. Okay. So it definitely is quadratic. From here, I'd probably put it in the calculator. In fact, we might as well do that now. So we go to menu, stats, and this has started to work again. No, it's not quite working. Stats, there we go. And then we're going to put those in like this. So 5, 10, 15, 20. I'm going to go across 75, 100, 105, and 90. So our answer is going to be somewhere around 15. Graph graph 1, and yeah, sure enough, it's quadratic. Okay, so the answer being, so the area is going to be minus 0.4 times the width squared plus 11 times the width plus 30. So once we've done that, we can find the maxima, and we'll probably just go into grapher for that. So minus 0.4, and there's no W button, so we're going to use X plus 11X plus 30. I'm going to put it in, I'm going to draw it, and there's our nice parabola. G-solve, we want to find the maximum value, and it's found it there. So 13.75 and 105.625. Meters squared is our final answer. Okay. The profit from selling ice creams depends on how many are sold. Okay, yeah, that kind of makes sense. That doesn't give us any clues. Ice creams sold, so they make a loss here, and then they start breaking even at when they've sold 2 ice creams. And these must be pretty spectacular ice creams. Okay. $15 ice creams, okay. So is this quadratic? Might be. It's definitely not linear, because it goes down and then it comes up again. So let's test. Do our little test. So 0, 1, 2, 3, 4. Minus 20, minus 5, 10, 25, 40. Okay. I'd take that back. It might be linear. So there's a difference there. Is it 15? Oh, yeah, it is 15. Yes. $15 ice creams. Okay. So it is linear, and it's $15 per ice cream. Not $15 cost, but $15 profit. Marginal profit. Wow. This must be really good ice cream. Profit based on the number sold. Okay, so if it's linear, so the profit is given as 15 times the, let's say the number of ice creams is X, minus 20. When we sell 0, we make a loss of $20. I'm keen to see what these ice creams are. They must be pretty spectacular. And we're done.